Hello, today we're going to talk about dry friction. So friction is the force that prevents objects from sliding relative to one another. Sometimes this force is going to be useful, like for example the brakes in your car. Without friction they would not be able to stop your car. Sometimes it's something that we're fighting against. For example, with a plane is going through the atmosphere. The friction force, the drag force on the outside of that plane is something we're trying to overcome with the engine. So this can be helpful or not helpful depending on the particular situation. Generally, we're going to have two types of friction that we're going to break this down into. There is dry friction. So dry friction is the friction between two solid objects sliding relative to one another, and they need to be in direct contact with one another. So if we have two solid objects in direct contact, we've got dry friction. If there's a fluid involved, that's going to be called fluid friction. So fluid friction is a solid body moving through a fluid, or if I've got two fluids kind of working against one another, that's also an example of fluid friction. So we're going to be talking about dry friction here in statics. Fluid friction is a very complicated topic that you'll get into if you take a fluid mechanics course. So moving on to dry friction, we're going to talk about dry friction, and most of you probably have a good intuitive understanding of how this works. It's pretty prevalent in everyday life. So for this, we're going to talk about this simple example over here. So we've got this blue box sitting on some sort of table, and we've got some weight, the Fg force. We've got normal force supporting the box from the table. We're going to have a pushing force that we're going to continually increase. So imagine I'm pushing on this box, and I'm just going to kind of push harder and harder and harder. And we're going to look at what happens to the friction force that's resisting that sliding motion that would occur. So if we had a perfectly rough surface, this means that sliding is never going to occur. What's going to happen is as I push harder and harder, I'm going further and further this way, the friction force pushing back is going to get higher and higher. And this is a perfect one-to-one ratio so that these two forces, the pushing force and the friction force, cancel one another out. That means that I've got net force equals 0, and when I have net force equal to 0, there's no acceleration, there's no motion. So this is a perfectly rough surface, and we're never going to be able to push hard enough to make this slide. In real life, however, we get something different. So what's going to happen is we're going to push harder and harder, and it's going to go further and further up this line. At some point, it'll start to slip. And so we deviate from this line, and what's going to happen is we're going to go further this way, so the pushing force becomes greater than the friction force pushing back. And so when that occurs, it'll start to actually slide. So we're going to divide this graph into three sections. We've got this first section where it's kind of a one-to-one ratio. We're going to look specifically at this point where it transitions, and then beyond that, we're going to have sliding occurring. So this friction force, the maximum friction force before sliding starts to occur, is going to occur at the static coefficient of friction times the normal force, and then it's going to drop down to the kinetic coefficient of friction times the normal force there. All right, so here is our graph. Section 1, the friction force and the normal force are equal and opposite. So this is like our perfectly rough surface, so no sliding is going to occur. That is going to be the relationship between the two until I get to my point of impending motion. So over here I've got no relative motion. Everything is going to be stationary. I go up to this point where the friction force, in addition to being equal to the pushing force, is going to be equal to the static coefficient times the normal force. And this is the point where things start to change. So this is known as the point of impending motion. So motion is just about to occur, but not quite yet. Beyond that, it's going to jump down. So as soon as I start to get this thing moving, it's going to get less force pushing back on me, and the friction force is going to be equal to the kinetic coefficient of friction times my normal force. This kinetic coefficient of friction is almost always going to be less than my static coefficient of friction. And so once that is exceeded, once I have more pushing force than my maximum friction force in return, I start to get relative motion. So this is going to be the box sliding along that surface, relative, and if there's relative motion, there's that sliding of one surface relative to another. So looking at these two values, this is the static coefficient of friction, so this is the point at which impending motion is about to occur. And that friction force is the mu static times the normal force. And over here, the friction force is the kinetic coefficient of friction times the normal force. So these coefficients of friction depend on the materials in contact with one another. It's a material property. You're going to need to look that up in some sort of table, or you're going to need to determine that experimentally. It's going to be fairly low for kind of slippery surfaces. So if I imagine basically two pieces of brass sliding relative to one another, those are going to have relatively low coefficients of friction. It's going to be easy to slide those things relative to one another. If I imagine something with a high coefficient of friction, I'm going to have something like sandpaper on a piece of wood. If I put sandpaper on the bottom of that box and tried to push it, it'd be harder to push than if I had something like metal or nylon that's going to have be more able to slide. The second part of this whole thing is going to be the normal force. So the harder I press down between these two boxes, if I put more and more weight on top of that box as I try to slide it, it's going to be able to exert a higher friction force backwards. So either one of these can up that point of impending motion, and it's going to up the resistance once I start sliding. So with that, that's all I have for dry friction. Thank you for watching, and I hope to see you again.